as a worksheet kind of correspond with those two word problems. Looking ahead this week, tomorrow we are going to review the first part of the chapter. So substitution, elimination, graphing, word problems. And then on Wednesday, you will have, I believe it's a 30-point quiz, might be 28 points, it's somewhere in that vicinity, on substitution, elimination, graphing, and a word problem. So that would be on Wednesday. Questions? Remember, the agenda is always posted in each week's set of assignments and activities on Google Classroom. And it's usually posted Friday night. So it's always there for you to look at and kind of see what's going on for the week. So if you'll take out your homework from the weekend, there was really 4 problems that you were asked to graph. So I want to just look at those 4 problems because I did not put them on Google Classroom for you to kind of check your work. So I want to go over them a little bit with you to kind of just talk about them. It was a worksheet. The first, I think, 4 problems of the worksheet were more like kind of creating inequality, but the last 4 problems were the graphing. So this is the first of the graphing, and I just want you to kind of check your graph and see if it looks similar. But I have the 4 inequalities. X is greater than or equal to 0, y is greater than or equal to 0, x plus y less than or equal to 8, 2x plus 3y is less than or equal to 21. And then, of course, the inequalities in y equals form I have right next to them. So I would say check your graph, but then also check your ordered pairs, the corner points, the vertices where the points are, the 2 lines are intersecting. So 0, 0, 8, 0 on the x-axis. The y-axis is 0, 7, and then 3, 5. So just kind of check those pieces. So does your graph look the same? Do you have those 4 points, those 4 vertices? So the second set is a little more interesting because it used a and b instead of x and y. When it uses a different pair of variables, your variables are alphabetical order, always independent first, dependent second. X is independent, it's first in the alphabet. Y is dependent, it's second in the alphabet. So I changed my x-axis to say A. I do usually label them if I have a different variable so that I know that that variable corresponds with the given axis. So the x-axis is now the A, and the y-axis is now our B. And then looking at the first value, we have A is greater than or equal to 0. So that I drew in red so that you could see it kind of a little more bold than just doing a black line. And then the second one, the B value is squished in between 2 and 6. So if it's Y is horizontal lines. Anytime you have a Y, it's horizontal. So here are those 2 horizontal lines for B. My graph has to be squished in between those 2 horizontal lines. So this inequality, 2 is less than or equal to B, is less than or equal to X. Means my Y values or my B values horizontally have to be in between. The one we did on Friday was our vertical values for X, where X was squished in between 2 numbers. So now my Y has to horizontally. So my graph had to be in between those 2 values. And then the last inequality that was given is 2A is less than or equal to B. I just flipped it around so that B, because B is my Y variable, I made sure that was on the left. So really this is Y is greater than or equal to 2A. And that has, again, that Y-intercept at 0. So check your points, those ordered pairs for the vertices. Make sure you have the shape of the graph. Are there questions on those 2 problems? So graph 3 used U and V. Again, I labeled my axes, the U and the V. I also moved over my V axis or my Y axis so that I could fit the points on the graph here. So V is equal to 0. I made that in red going horizontally. So my Y value is 0. That means I'm not moving up or down, just placing a point going horizontal. Anytime it's Y, it's horizontal. The second pair, This is my u, which is really x. So now my points go in between 6 and 15, but anytime it's x, it's vertical. So that's why I have these two vertical lines here on my graph. So everything now vertically needs to be in between 6 and 15. So my graph exists in between the values of 6 and 15 for x or for u, however you want to think about it. And then that last inequality becomes negative 2/3 u plus 12. And I graph that way at the top. I had to make a couple extra spaces for that, 2 extra spots. And then that's moving down 2 and right 3. So all 4 of those, we ended up getting a shape because there were 4 lines, 4 inequalities. We have a quadrilateral, a 4-sided figure. So if I had 3, I have a triangle. If I have 5, I have a pentagon. So the number of lines correlates with the shape. Question, Madison.
So does it not matter really quick the coordinates? Can you like or do you want them to be
Like listing these, or
yeah, like should they be in the corner or should they be
where they are on the graph?
Okay.
Other questions? All right, the last one was tiny, so all of these other ones turned out to be fairly large. The last one, this side, when I was taking a picture of it this morning, it's definitely a little cockeyed here, a little skewed. But this one goes back to x and y, and I think people feel happier using x and y because you're so used to using x and y than it is the other variables. But x is greater than or equal to 1, y is greater than or equal to 1. So I have those labeled here, horizontal for y. Here's my vertical for x. And then, as I said, this is a tiny graph. So the third inequality ends up being y is less than or equal to negative 2x plus 6. So I went up to 6, down 2 over 1. And then the final inequality ends up being negative 1/3 x plus 8/3. That one's the evil one because it's a decimal. When you're graphing 8/3, it's 2 and 2/3. So you're approximating, like I went up 2 and then I went up about to where 2/3 was. And then I'm using my slope of negative 1, so I'm going down 1 and over 3. So my second point should be 1 below, so it's not going to ever connect in the corner of a box, so it's going to connect underneath that. And then again, I went down 1 and over 3 to get another point on that line. Does anyone have questions? I know it's trickier once you're graphing multiple lines and trying to get them to shape. Just take your time. Were there questions on the first half of the worksheet? Just those forward, a little trickier. So today we are going to do this same thing. We are going to be graphing. However, we're going to create our own inequalities. So we're going to come up with our own inequalities from the word problem. We're going to graph it, and then we're going to try and answer a question in the word problem. And that question might be, what's the maximum profit that we can make? Or maybe what's the minimum cost of buying whatever type of products I need to buy to run a company. So we'll be working through creating our own inequalities. We'll be graphing them, but then there's going to be some type of goal, and we're going to try and answer that question, our goal. So this is in your packet. It's linear programming. It should say J2 at the top. So again, linear programming, day 2, or part 2. On Friday, we pretty much did the exact same thing, except we didn't really look at a word problem. The last problem we did was a word problem, but we didn't, no, I think that was the day before. I don't think we did any word problems on Friday. We were just kind of focusing on graphing the multiple inequalities. So again, this is part 2, but the application part now. So how can we start applying this instead of just kind of graphing and saying, okay, here's my graph. So 2 terms today. An objective function is going to be an equation. And that equation we're going to be using to find a maximum or minimum value of our graph or of our system. So sometimes you might see it as an objective quantity, sometimes it might be called an objective function, but it's an equation, and that is kind of important to think about. We will not be graphing this equation, we're going to be using that equation to answer our question. So whatever question is in the problem, that equation is going to help answer the question. We will not be graphing it. It's an equation, it's not an inequality. And then the other term is the corner point principle. And the corner point principle says that the max or the min is found by using the vertices of our feasible region. Remember that shape where they all kind of connect. So what this is saying is that one of those points, one of those corner points, is going to give us a maximum value if we're looking for a maximum value, or a minimum value if we're looking for a minimum value of the objective function. It's not going to be in the middle, because if it was a point in the middle, then I should have a value that would be in between the max or the min. So the corner points, there might be 4, there might be 3, depending on the shape that we're given and how many inequalities. But those corner points will always give us the maximum and the minimum values. And we'll be looking for one or the other. So we're going to see if we can kind of take one of these big problems and work through all of the pieces and see if we can try and find our end goal. And the first problem deals with a toy store and having some stuffed animals at the toy store, and they are lions and giraffes. Why not? Although I like elephants, that would be my favorite animal at the zoo, but giraffes are like just stunning animals. The way they're spotted, like beautiful, their long heads. So a toy store makes animals, or a company is making animals for the toy store, and they're making lions and giraffes. It decides to make no more than 75 animals in all. So that's the total number of lions and giraffes that it's making. And it says it's going to keep the number of giraffes to be no more than 5 more than the number of lions. That's a little wordy. All right, so we know we have lions and giraffes. It says represents the constraints with a system of linear inequalities. Remember we said constraints? That meant like restrictions. So, which is essentially making a system of inequalities to restrict our graph to a certain area. It also says that we're going to use X for lions and Y for giraffes. Now, this might not always be given to you, and you might have to choose what your X and Y represent. So, usually the first thing in the problem, I make X. The second thing in the problem, I make Y. So sometimes you have to pick the variable and what it represents. Read through the problem again. We have a toy company, 2 animals. Look at the first part of the sentence. It decides to make no more than 75 animals in all. See if you can create an inequality that states no more than 75 animals in all. So, Helene, how could I take no more than 75 animals in all and try and write that as an inequality? So it is x plus y, but that x plus y is less than or equal to 75. So my two animals together must be less than or equal to, because it says no more than, so it can't be more than 75, but it can be 75. So my animals together, both of them, I can't make more than 75 because the toy store has other things. So like think when you go to the zoo, I don't know if anybody's been to the zoo lately, but as soon as you come up the big elevator, and then there's the restrooms, and then right in front of you, they have that toy store, like as soon as you enter, the stuffed animal store at the zoo. Trinkets, anything you want from the zoo. So they only are gonna have a certain number of lions and giraffes because they need other animals as well. So that would be our first inequality. No more than the two of them together, x plus y. Can't be bigger than 75. All right, the next one seems this is the wordy one here. The giraffes to be no more than, so again, that's gonna mean less than or equal to, so less than or equal to. I'm gonna kind of just write this equation out or inequality out as I read it. Giraffes, no more than. Giraffes are y. They can't be more than, so they have to be less than or equal to. 5 more than the number of lions. Madison, how would you write 5 more than the number of lions? Yeah, 5 plus x. So it's going to be 5 more than the lions. So if I have 5 lions, I would have 10 giraffes. So you're going to have more giraffes than you have lions. 5 more giraffes specifically, no more than that, than the number of lions. All right, so now I have 2 inequalities. But I'm going to tell you there are actually 2 more. And we call them our implied inequalities. They're not actually in the problem. There's no other information from the problem that I can write. But I have to write 2 other inequalities because we're creating objects. Does anybody know what those 2 other inequalities would have to be? Think about if you're making something. What kind of other restriction or constraint would you have on making something? Dave, do you have an idea?
Would it be x is less than or equal to 75?
I see what you want to kind of think about because you know there has to be 75, but you kind of already have the 2 of them together to be 75. I'm going to say that individually, I'm going to write individually. We're going to have a restriction on them. Any other ideas? Why 0?
Well, because we're talking about animals.
Yeah. Nice job. So we're talking about animals. We can't make a negative amount of animals. So a constraint is restricting them from being a negative amount. So I have to say then that if they can't be negative, they could be 0 because maybe I'm not making giraffes or maybe I'm not making lions. But they have to be bigger than 0 as well. So these we call like our implied inequalities or obvious inequalities. If it doesn't give us other information, we have to include these because I cannot make a negative amount of animals. I can't make a negative amount of any type of object. So anytime we have application problems, we're going to have those implied constraints. All right, so part B, let's graph this. We're going to graph those inequalities. And then it says record the coordinates below for the vertices. So just like on Friday, I'm going to kind of just come in a couple. just so that I'm not right on the edge. So my x-axis and my y-axis. And this inequality would be negative x plus 75. So I know everything has to be above the x-axis and everything has to be to the right of the y-axis because of those first two. So x greater than or equal to 0, y greater than or equal to 0. So that means that I have to have x being greater than or equal to 0. It's got to be positive. And I need to have y being greater than or equal to 0. So that's this line here. Because here's y is 0. And I need to be above it. So just kind of reminding myself that I can't go below. What do you think we should count by? Okay. Yeah, I think 5s work. I mean, try and go, the smaller the better. You get a bigger graph, it's a little more accurate. And label it so that we know what you're counting by. You don't have to do all of them. But whatever you do for y, to get the y-intercept to be on the graph, count the same way for x. Then our slope is still proportional, because if I go up 1 and over 1, I'm still going up the same distance for my x and y values. So our first graph is x plus 5, our first line. So going up to 5 and then up 1 over 1. And then the next one we have is negative x plus 75. So we're counting all the way up to 75. And this time it's down 1, right 1, because the slope is negative. I usually try and highlight, make the point where they intersect a little bigger so that I'm seeing they are crossing. And then again, making that other place where they intersect a little bigger than the other points. My two diagonal lines, both of them say less than or equal to. So remember, less than means below. So any point on the line, I need to go below that point on the line. That's what less than means. So any point on my line, less than is below. My other line, negative x plus 75, any point on that line means below. So I can see the shape is almost a triangle, except for this little piece on the left side. So see if you can shade your region. Apparently I shouldn't try the highlighter because now I have a little spinning wheel. After you shade, see if you can get those corner points or the vertices. So try and get the vertices of your graph. So this shaded region here. And then you want to list those points. The vertices where our two lines intersect. don't forget about that origin. They do intersect at 0, 0. Where do they intersect? So say again. 35, 40 up in the middle. So up here, she's saying 35, 40. Yeah, that looks good. 1, 2, 3, 4. How about any other points? Where else do they intersect? And 0, 5. Nice job. So those are the 4 corner points, the 4 vertices, the 4 places where both of my inequalities are intersecting with each other. So 2 of them on the x-axis, 1 on the y-axis, 1 in the middle of the graph. And that's what we did pretty much on Friday. There is one final part to this problem. And that final piece wants us to take this information and now actually answer the question or solve the problem. And the last part of it says the profit on each lion, which remember lion was our x, is 20 bucks. So a lion is going to gain or give us 20 bucks profit. The profit for the giraffe, which is y, is $18. How many of each kind of animal should the company make to maximize the profit? Now remember, this is just 2 things that this company, the toy store, is selling. But we want to say just with those 2 pieces of information, how many should I sell to maximize the profit? And this is where we're going to write that objective quantity or the objective function. This is our goal. Our goal is to maximize the profit. So I'm going to use a P for profit. What would the equation look like if a lion is 20 bucks profit and a giraffe is $18 profit? What would that equation look like? Addison, cool. How would that look? So what would our equation look like for profit? How are we going to make money? Yeah. We're going to make money by $18 times how many ever lions I sell, adding that with, or I'm sorry, $20 times the number of lions, adding that with $18 times the number of giraffes. So the last thing that we have to do is to figure out which one of these points, it's the corner point principle, which one of these points gives us a maximum profit. And if I take those ordered pairs and plug them into my objective function, one of them should give me the most amount of money. Now, obviously, 0, 0 isn't going to, and I'm pretty sure 5, 0 isn't going to as well, or 0, 5, not 5, 0. 0, 0 is going to give me nothing. 5, 0 is still going to give me a pretty low number. However, we also have 35, 40 and 75, 0. And I'm pretty sure one of those pairs is going to give us the most amount of money. So corner point principle, one of the corner points gives us a max, one of the corner points gives us a min. We just need to figure out which one. So we would plug in those 2 values for x and y. It's not asking for a minimum, and if it's obvious that those are way minimum, they're not going to give us a maximum value. So again, the question is, how many of each kind should the company make so that we have a maximum profit? That's our goal. So the reason we're kind of looking at this question, how much should we make so that we have the most amount of money? Okay, do you know how much money we make if we sell 35 lions and 40 giraffes?
It would be 14, 20.
20?
Yeah.
And then what about 75 lions with no giraffes?
1,500.
15. So the most amount of money we can make is $1,500 on 2 animals. Doesn't seem too bad. If we want to answer this question, how many of each kind should we make? Well, $1,500 is our max profit. And according to this, we should make 75 lions and no giraffes. Now, the next part of your business, if you have a business, thinking like, would that be best for your customers if you didn't have any giraffes? Probably not. So if you actually have the business and you're looking and saying it's only a difference of $80, I probably want to sell some giraffes too. But if we're actually relying on the data, then the data is telling us we're just going to sell lions. Again, I like giraffes. I'd be pretty sad if there wasn't a giraffe there. Especially if I wanted to go buy one for one of my kids. But they have way too many stuffed animals to begin with, so we don't buy stuffed animals. So we have 5 more minutes, maybe 6. I'd like you to read through the next problem, and we're going to see if we can create the constraints. I think that's one of the difficult parts. Can you come up with the inequalities to represent the problem? A potter wants to make and sell bowls and plates. If you get to take pottery here sometime over the next couple of years, Mr. Hilligus is awesome. He makes amazing bowls and cups and vases. He's very talented. So take his class at some point. I wish I could even go up and just hang out with him a couple of times. A bowl uses 5 pounds of clay. A plate uses 4 pounds of clay. The potter has 40 pounds of clay and wants to make at least 4 bowls. So it does give us X and Y, X being bowls and Y being plates. So read through it once, read through it a second time. See if you can try and pull together the information. I know it looks like we're talking about pounds of clay, so that probably has to make an inequality together. The last part of the sentence, making at least 4 bowls, that probably has to be some type of inequality. Riley, do you think we can come up with an inequality?
X plus Y has to be greater than or equal to.
I'm going to say you are so close, because I think you're going off this last part here. Wants to make at least 4 bowls. Which variable represents the bowls? Yeah. So it's just going to be X, because it's just talking about making at least 4 bowls. So I need to make at least 4 bowls. If I go off of the same thing, it doesn't tell me anything about plates, but we know we can't make a negative number of plates. So the plates, which is Y, is going to have to be bigger than or equal to 0. So at least 4 bowls, but it doesn't give us a restriction on plates. Besides that, I can make 0, but I can't make anything less than that. How about one other inequality? What else are we going to have up here? What other information is given? Faith, what other information is given for us?
I said 4y plus 5x is less than or equal to 40.
And what are you using to kind of get that information?
Well, since a bowl uses 5 pounds of clay to make, and then a plate uses 4 pounds of clay, it can't be more than.
Yeah, excellent. So this is kind of taking into effect that we have a certain amount of clay to use. The number of bowls with 5 pounds, the number of plates with 4 pounds, and then the maximum amount of clay we have is 40 pounds. So because that represents the pounds of clay that we're using, we would want to create an inequality to go along with them. Any questions on those inequalities? So see if you can try and finish up this problem graphing these 4 inequalities. Again, the x is greater than or equal to 4 because they gave us a restriction on the number of bowls that we have to make. Y is greater than or equal to 0. I can't make a negative amount of plates. And then that last one, solving. Get the y by itself, take the 5 to the other side, and then divide by 4. This one only goes up to 10, so we probably can just count by ones because this is a big graph. So again, homework tonight is in the book. There are 2 problems like the problems we did today. So you have 2 big problems, and then the other 3 problems are graphing for a total of 5 problems tonight. Tomorrow we'll go through probably one more together, or at least start one more together, but tomorrow's our review day. Have a fantastic day. Thanks, you too.